Okay, we're back again for Advent of Code 2022 for day 12. I'm trying to bounce back from an unfortunate instance that happened yesterday with WSL crashing, leaving me completely unable to do anything code related until rebooting my computer. Though, considering, where is it? We still went like 200 to 210, which is better than some of the days, even though I had to reboot my entire computer and spent a few minutes trying to debug the problem. I consider that pretty good. A bit of a confidence boost that we would have hit leaderboard here if it weren't for that after a pretty a dry spell of getting any points, so I'm happy about that. Proves that, you know, there's still a possibility to earn some points even as the problems get harder. We were a little bit disappointed in not getting points for so many days. I think the ability to just like read the question really quickly and code up something really fast in Python benefits me a lot in the earlier parts of the month when the problems are a lot easier. But then this is where really figuring out what algorithm to use or coming up with an efficient solution becomes really important. So hopefully proving my ability to actually do this in the latter half of the month, the back half, if you will, the back 9 holes, except more like 12, the back 12 days. Most one higher. Can we move down? Okay. So it's if f is less than or equal to going on here? Why would this not work though? Oh. Oops. I'm so confused. Why are these numbers just all wrong? Oh. What is going on? Why are these numbers so big? Hello? Was I not copying the sample properly? Okay, I literally do not know what's going on with my input parsing. Something is going very wrong. But I don't know what it is, so that's kind of annoying. Like, what is this? Oh. Okay. This is not gonna make any sense. This is doing some like weird stuff. I got paranoid about. Okay, let's just try to explain what's going on afterwards. I'm gonna just start a new terminal because I have no idea what's going on. Okay. Now our input is correct at least. Okay, that was a really weird side effect of using WSL, and I'm thrown for a loop. Where was I? Okay. Our search isn't going correct? So... Is it this way? So we started here. We will just play a little bit of debuggy. So we could go here. And if we're at 0, 1, go to any of these. I mean, I think that's fine, right? And our... Oh, of course. I think... This is the route we have to take? Okay, so... And then I think it's something like this, no? Oh, A is the lowest, I guess we should... of course. Says we do this in 25 steps. The location that should get the best signal is still E. Why does it seem like we are taking a shortcut to get here? Elevation of the destination square can be much lower than the elevation of your current square. I mean, this should be a pretty straightforward question. After sorting out all these like weird issues with my input reading. Yeah, so if the next place we're trying to go is at most one bigger, so that has to be greater than yeah, that should be fine. Does it matter that we to avoid any ambiguous elevation be at most one higher than the elevation of your current square? That is, if your current elevation is m, p depth. What else do I want to look at? I want to look at board of p. Oh, the E counts as elevation Z. Okay. I see. And what P board P is in. We can either be at a Y or a Z. Right, because what's happening is we're at the... It says we're visiting like the V, and we're somehow jumping in. Yeah, we're jumping to the end, so it's like... I mean, I should just not special case this, and I should just reassign the board values probably. Like that, right? Okay, so that's 31. So then, if we run it on the real input, we should get this. Okay. Shortest path from any square at elevation A. Start is K. So like that. So that'd be 29. Okay. Weird stuff that I messed up. I'll explain it after the fact. Well, actually, maybe we'll explain it now. Because of what happened yesterday, I was concerned that my WSL was going to crash. And so because of that, the way to fix stuff apparently is to run some of these commands to restart the daemon that manages WSL. And you have to do it from PowerShell. And the way that I wanted to put a reminder for myself in here is to put these commands, so if something goes wrong I can just quickly open up a PowerShell and copy and paste stuff and run it here. Well, unfortunately, this had a weird side effect of apparently with the script I use here to run what's on my clipboard as input, it was taking what the text I wrote here and appending it to the input of my clipboard. So that's why even though this sample that I was highlighting was only a few characters long, it was trying to parse a bunch of weird random stuff. It was this text here. Why is it that trying to access the clipboard from Windows brought this text in as well as what was in my clipboard? I'm not entirely sure. But that's why I struggled so much on today's problem initially. I wasn't able to debug what was going on. But yeah, I will jump forward to the future and just explain the problem because it's pretty straightforward. Okay, we should be back now. So let's jump into the problem. So this was a pretty standard BFS question. So day 12 is hill climbing algorithm. we are given kind of this height map of the local topography, I guess, the local area. And letter A represents a very low point. A B represents the next lowest point all the way up to Z. So we have 26 different levels of elevation. And there's a point S, which is our start position, conveniently, and E, where we want to get the best signal. E, of course, standing for end, so we can have the start and an end. And we want to figure out how to get from S to E in as few steps as possible. So that's the first hint that something like this, a breadth first search would be excellent to solve it with. The only interesting part about this question is we can only move at most one step higher from our current location. So if we were here, the start is considered a height A, so we can move to here. But from, say for example, this point B, we could move to C, because C is one higher than B, but we can't jump to Q. We would require our, climbing equipment to get there. And we don't want to pull out our climbing equipment. We want to just step up these small elevations. So in this particular example, this is a path that we actually need to take to get all the way to the top. It kind of spirals around and then goes from the X to the Y to the Z and then to the end, instead of just taking a direct route here. So the question is figure out how to do that in the fewest possible steps. And so what does the code look like for this? Well, first we have to parse the input. And so I'll change this over to using the file input module afterwards. But just for the sake of demonstrating examples, it's pretty simple. We can loop through the entire input, look at all the lines, and just assign to a dictionary. I prefer representing graphs as like a sparse matrix, where it's a dictionary where the key is like a XY coordinate and the value is what the value is in it, instead of a 2D matrix. The main reason I like doing that for these questions is because you can just do a check if the key that you're looking for, the position you're trying to go to, is in this dictionary. And if it's not, continue, rather than coding in some like boundary conditions, checking to make sure we don't access something outside of the grid. So that's just a personal preference, and I find this sort of stuff works well. So we'll iterate through all the lines in the input. If we see an S, we will keep track of what that start location is. And actually, let's also do this. So something interesting to note that I didn't realize until I read the question a bit closer is that we implicitly consider this end to be of elevation Z and the start to be of elevation A. And so if we see those locations, kind of just replace it in the grid with an A or a Z. And also keep track of where the start and the end is. So then, all that part one is asking is, what's the fewest steps we need to get there? So we just have to code up a breadth first search. And here's a pretty simple implementation of that. We start with our start position. We keep track of the spots we visited before. And while there's still stuff to visit, we pop off the queue. If we've seen the spot before, we don't do anything. If we're at our goal, we can return how deep we've gotten. Otherwise, we add the current location to the things we've seen. And then for all the neighbors, so this is a helper around my point class, but this is basically, this could just be rewritten as something like, you have different directions, which are like going to the right, going to the left, going up, going down, and then like for dx, dy in DIRs, we say the next point is going to be, our current x plus dx, and our next y is going to be the current y. And then use that to determine what the next key should be in neighbors. This is essentially what my utility function over points is doing, just implemented somewhere else, so I don't have to type all of this every single time. So neighbors basically just returns adjacent points in the 4 cardinal directions. So the 4 adjacent points. If we are trying to load a location outside of the grid, aka the neighbor is not on the board. I don't know why I called this H. Like, I feel like N makes so much more sense for neighbor. We don't do anything. Otherwise, we have to check this condition that we're only moving at most 1 step higher. And so we can convert the next location to a number based on its ASCII value and subtract 1 and make sure that's less than or equal to where we currently are. And if both these conditions are met, then we push this into our queue of next locations to visit. If we exit out of this loop, this is the big BFS loop, and we haven't found the goal yet, that means it was impossible to get from our start location to the goal. And so we just return a really big number. And so if we have that, and we run this on this input, we get 31, which was the expected thing here. And if we run it on the real input, we get 408. Great, that's what we expected. So part 2 basically asks, rather than starting at only the start location, we can start at any location that is marked with A. So any of these starts. And because we have this nice BFS function, it's actually pretty straightforward. We just have to iterate over all the locations in the board that are A and use those as our potential starts for our BFS, and then pick the smallest value returned by them. So it turns into just a nice, one-line modification to answer part 2. So if we run this over the sample input, we get 29 as the next best thing, which is here. And if we run it on the real input and I refresh this page, we get 399. So pretty straightforward BFS problem with just a little bit of a twist on that we can't just always visit every neighbor to the cardinal direction. We have to make sure we're moving only a little bit uphill if we're trying to go uphill. I learned something new today about WSL trying to inject stuff into my clipboard, so that's fun, and I'll know not to do that in the future. I'll find some other way to keep track of what commands to run if WSL crashes. But yeah, pretty straightforward day. Thank you for watching, and I will be streaming again tomorrow.